Hey guys, welcome back to SudokuManiacs. So today we have an interesting variant for you. And this is an Anti-Knight Killer Sudoku. And this was hosted on our website yesterday. Sorry, that is the 30th of June. Now it so happened that it turned out so tough that roughly half the people could not solve it. And of the 50% that solved it, the fastest solver was T-Twonk of Estonia, the 2016 World Sudoku Champion, who took just about a few seconds more than 8 minutes. So that gives you an idea how tough this puzzle turned out to be. Yet, being tough does not mean it required guesswork. So I did receive quite a few requests from my patrons and friends asking me to create a detailed walkthrough on this. So I thought, why not? And if you're not aware of what the rules are for an anti-knight Sudoku or a killer Sudoku, I have added links to the videos up there at the top of this at the top of this video. So you can check them out to understand how to approach an anti-knight or a killer Sudoku. And this Sudoku is a combination of those two. All right. So the rules are that the digit cannot repeat at a cell which is at a knight step from itself. And when we say a knight step, it's like a knight's move as in chess. Additionally, the digits inside these marked cages will always add up to the number that is mentioned on the top left corner of the cage. So for this cage, these two numbers will always add up to the number 4 because we have the number 4 mentioned at the top of the cage. All right. So without wasting much time, let's get on with this. And the start is very obvious, the central box. We have 4 cages, and as you're aware, the sum of all the digits within a constraint, whether it be a row, column, or a box, will always be 45. Now we know for sure 16 can only be formed by 7 and 9. So 16 plus 8 is 24, 8 32, plus 5 37, which gives me an 8 here. Right? Now, most of the times we miss this. Let's have a look at column 5. I have these 3 cells adding up to 16. I have these 3 cells adding up to 8. So together these 6 cells will add up to 24. And I have the 8 here, which is again, so the 7 cells become 32, which means these 2 cells have to add up to 13. So to get the sum of 13, for a 9 I would require a 4, and for a 7 I'd require a 6. But obviously, since these 2 cells add up to 8, I cannot have a 4 because I can't place 2 4s in within a box, right? And the digits do not repeat inside a cage any which ways. So this has to be a 6 and a 2, which makes this a 7 and a 9. Now, a sum of 3 cells adding up to 22, there are only 2 options. Either it will be 985 or 967. But with the 8 already available in the row, it has to be 6, 7, and 9. Alright? But let's not forget the knight step. So these two digits, 6 and 7, both are at a knight step here. So this has to be a 9, and this becomes a pair of 6, 7. So this, again now, row 5, I have these 3 adding up to 9. These 3 adding up to 22, which is 31. And with this 8, the total is 39, which means these two have to add up to 6. Now for the sum of 6 in 2 cells, it is either 1 and 5 or 2 and 4. But we already have a 2 in the box, so this has to be 1 and 5. And with these two adding up to 5, obviously this cannot be a 5 because that would require a 0 here. So that's a 1, 3, 4, and 5. And this way we wrap up the central box. So this would be 2, 3, 4, 2, 3, 2, 3, 4 because this 4 is at a knight step. Good enough. Now look at this. Oh, so this 4 was 1, 3, 1, 3 because I cannot have 2 and a 2. 21 plus 20 is 41, which means these two also have to be 4. So this will again be 1 and 3. This is a 12 and 16. So that's 28, which makes these two to be 17, which is only possible with an 8 and 9. And for the sum of 11, if this is an 8, this will become a 3. If it's a 9, it's a 2. So the only possible numbers here are 2 and 3. Now, the first thing I notice is for the sum of 20, the minimum number will have to be a 3 in 3 cells, right? Because 3 with an 8 and 9, the other two largest numbers will form 20. Or the converse way of saying is 1 and 2 can never be part of a 3 cell cage which adds up to 20. So the 2 has to be part of this block of 21, right? So with this 2, these are at a night step. So the 2 is possible only in these two, correct? So these two cannot be a 2. 2 is at a night step here, so this has to be a 2. Now there was, always remember the night constraint. Let's have a look at row 4, column 7. I cannot have a 1 or a 3 here because in whichever cell these two come in, one will be in the same row, the other will be at a night step. So 1 and 3 can never be at R4 column 7, right? That's row 4 column 7. So 1, 2 is there in the row, 3 not possible, 4 is in the row, not possible, 5 is possible, 6 not, 6 and 7 are already there in the box, not possible, 8 is at a night step, and 9 is in the box. So we have a direct single 5 available there. You always have to remember these night constraints because they play a very important role wherever the night constraint is used, because it helps in eliminating a lot of possibilities. All right. So now that we had this, so for, okay, 28 plus 10 is 38. So I require a 7. 7, it can only be 1, 6, 2, 5, 3, 4. So for now I'm putting in all the options. And we'll try to see how many can we eliminate. If this is a 6, this will require a 2 here, right? Which is not possible because the 2 is locked in the sum cage of 9. So we can remove the 6 and the corresponding 1 here for the sum of 7. For a 5, I would require a 3, which again is not possible. So even the 5 is not possible and the corresponding 2 is eliminated. 4, obviously not, because I cannot have 4 plus 4. So, oh yeah, the 3 goes out. So for a 3, this will have to be a 5, which is possible. So we leave it. For a 2, this has to be a 6. And for a 1, that has to be a 7, which is again not possible here. So for the 1, I can remove. So I have this 2, 3, and this is a 4, 5. Now this is a 21 plus 12, 33. That means these two have to be 12. Now for 2 cell cages adding up to 12, it can be 3, 9, 8, 4, 5, 7. Now 5, 7 is ruled out because I have 5s already given available in column 6 and 7. So 5 and 7 can never be apart. 4, 8, 4, 8 is possible. I have a 3, so this has to be this can be a 9, this is a 3. Which means if these two also add up to 12, this also will be 4, 8 and 9. Right? Hmm. And okay, sum of 8, which means 1 has to be part of this. 9 cannot be the part of this, so 9 will be locked here. 28, it can be 9874 or 9865, which means 1, 2 and 3 are not possible. So 1, I'm sure, has to be logged here. All right, let's see where do we go on from here. Yes, this cage of 12. Now 12 cage, or rather a cage with sum 12 with 4, can only be 1, 2, 3, 6 or 1, 2, 4, 5. Right? So 1 cannot be here. So 1 and 2 are part of this. Okay. Where do we go? 1 cannot be here. 2, 3 possible. 4 possible. 5 possible. 6 not possible. All right. 5 and 6 are both locked here. 7 cannot be here, so 7 is part of this. Oh, my bad. Sorry, this cannot be a 1 because it's as a knight step. So now when I look closely, yes, row 7. 1 cannot be in box 7 because it is locked in this cage of 10. 1 cannot be in box 8 because I require the sum of what the number 1 in the sum of 8, which means this has to be a 1 somewhere here, right? Now comes the crux of this whole thing. For a sum of 12, now I know for sure I can never have the number 9 in this sum of 12. The reason being, 3 cages adding up to 12, and if one of them is a 9, the other two have to be 1 and 2. Correct? But now the one for box 9 is logged in row 7. So I cannot have a 9 in these two. This obviously is not a 9. And when I look at box 7, especially row 9, 9 can never be part of a 3 cell cage adding up to 10. This has to be a 4, 5. So in box 8, the number 9 has to be in row 9. Row 9 column 4 is not a 9. It can never be a part of a cage which has the sum as 8, which means this has to be a 9. And with this 9, this you get a 3 here, which makes this a 9 because these two add up to 12, because 21 plus 12 was 39. And now that we have our breakthrough somewhere, 9, 9, 9 has to be part of these three. It cannot be a part of 10. This is at a knight step, so my 9 has to be here. Alright, 9, 9. So 9 cannot be here because of the knight step. This cannot be a 9. This is my 9, which makes this an 8, 9. So let's put the 2 here first. So this cannot be a 9 because the same row, this 9 is at a knight step here, which gives me a, 9. So 9, 9, and the 9, which pushes the 2 here. So I can eliminate the 2. Alright. Now this 2, 2. It cannot be here. And 2 also cannot be part of this cage of 16 because if the 2 was here, these two will have to add up to 14. I cannot have 2 sevens. So 2 cannot be here, it cannot be here. This has to be my 2. Alright. And since 1 also is part of this cage, it has to be one of these two. This is not a 1. So I can eliminate the 1 from here, which means 1 is part of these two. Alright. Where do we go next here? 9 and 2, 11. I require a sum of 21. So these two have to add up to 10. 1, 2, 3 have been used. So this has to be 4, 6, which makes this 5, 7, 8, 5, 7, 8. Now with this 6, 7, if you remember from what we had discussed in the previous or the first Anti-Knight Sudoku, if two adjacent cells have the same pencil mark, then this will never be a 6. The reason is, if the 6 were here, it would be in the same column, or if 6 were in the column 9, it would be at a knight step. So we can safely place the 4 here and the 6 there. So which makes this a 3-5. 4 cannot be here, so this can be a 4, this can be a 4. Okay, so some breakthrough. Oh, this was a 3, so why do we waste time here? 3 and a 3, because 3 cannot be a 3. So this has to be a 2, 4, 8. Again, 8 cannot be here, 2 we already have in the column, so this is a 4, which makes this a 2, 8 and a 2, 8. Alright, so missing numbers 1, 2, 3, 4, 5, 6, 7, 8. And the 1. So 15 plus 1 is 16, so we can happily place a 5 here. So that's the 7, 8, and that means 2, 4, 6. 4 is there, 2, 6, 2, 4, 6. Next. Okay, for 9, these two have to add up to 7, right? 7 possibilities, just like we saw there, were 1, 6, which is not possible. 1 is at a knight step, and 1 is in the same row. So 1 and 6 cannot be here. 2 is already in the box, so 2, 5 also is eliminated. That leaves me with a 3 and a 4. But with a 4 here, this becomes a 3, this becomes a 4. The knight step, right? So this has to be 1, 2, and 5. 5 again cannot be here, knight step. Oh, I got a 5 here. So this has to be a 5, this becomes a 1, which pushes a 1 here. And the last digit 2, which makes this a 3 and a 5. So this would be a 4 because these two are to add up to 7, which pushes the 4 here, and I get a pair of 2 and 6, right? So 4, 4, this cannot be a 4 by classic rule, as well as the knight step. So this has to be a 4. I eliminate the 4, so this becomes a 4. I have a 2, so that's a 3, 2, and a 2. And now I have 1 and 2, total is 3, so the last number has to be a 7. 7 cannot be here, 7 cannot be here, so by classic rules this has to be a 7, this becomes a 1, and the last digit 8 and a 6, right? So by classic rules 6, 8 have to be here, 5 here, so 9, 8, 6, 5 are the 4 numbers. 6 at a knight step, so that's an 8, 6, 8, 7. With this 8, this has to be a 2, this has to be an 8, 2, 6, 6, 7, 7. So that becomes a 5 and an 8. With the 7 here, this has to be a 7, 6. 7 and 6, 13. So this becomes my 3, which pushes the 5, 4, and a 1 because you are right. So this also has to be a 5 and 8. Okay. What are the missing numbers here? 6 and 7. Alright. 1 cannot be here, so this is a 1. This has to be a 5 and an 8. What is missing here? 7 and an 8. Okay. So that's a 5, 8, 5, 8. So the 7. Now everything falls in place using the classic rules. And 3 finally, and when you submit, it says okay. Yes, the system says we are correct. So the crux of this whole puzzle was in identifying the 9 in row 9 column 6. And once you were able to do that, everything falls into place beautifully. Hope you guys enjoyed the puzzle, and now after this video it gives you a better understanding of what to look for when you're solving an anti-knight or a killer Sudoku. or better still, if you're solving a combination of those two. Do let us know in the feedbacks what you think of this. And till the next time, happy solving.